All right. So you good to go over the assignment then?
I get it somewhat. I can definitely see where you're having your crossroads. Uh, okay, good. Um, yeah, for example, with the matched pair data, on question 1 on the concepts. Um, what was your question exactly? I don't.
Oh, mine
Because
was about number 2. I understood like what matched pair data is and everything. It was more like the
yeah,
difference in the hypothesis test because I was reading over in the book about it, and basically with matched pairs, you find the data for both like the pre-test and the post-test, and you find the difference, and then you can use that, and it's basically the same as a one sample t test with sigma unknown.
and that's where they're, even though it's two different observations, they're still pulling from the same population, right?
Yeah.
Okay. So that's where it would come in to be just a one sample t-test then, right?
Yeah.
Okay. Okay. So I got that part then. Um, sorry, hold on. Let me trying to find. Okay. The graph part on 3. Um, so laptop I'm using is a Mac, and getting graphs on a Mac is different than it is on a Microsoft.
Oh.
I don't know why they had to make that type of difference on a Microsoft program. So um, I don't know. I was having a hard time like figuring out how to do that with a Mac, making a graph.
Yeah.
I mean, I guess I'll just keep looking around until I find something. But I didn't get the graph for 3 on the
Okay.
part 2.
I think that was the only graphing part we had to do. So on
Oh, you
our
still there?
math, so even when you graph using Excel on a Mac is different than with a PC.
Yeah, there's just some parts of it because I'm like even when I took this last year, I was having a hard time like finding out how to do that because everyone else around me had PCs, and I don't know, just trying to watch the tutorials on YouTube was one of the best tutorials. Okay, I don't know. I'll just keep looking around on how to do that because really that's more of an individual thing, anyways, right? So,
Yeah. But let's see. So let's go over just the application part really fast.
okay.
So for the research question, I got when you use the new loading and unloading procedure, is the wait time going to be different than the original procedure? So basically, if we change it, is it going to be more efficient than the way we were originally doing it for the assembly line?
Um, Okay. I'm having a hard time with this one. Sorry.
No, you're fine.
All right. Okay. Where are we at here?
So
What time?
we are on the application portion. And then we're going to do, we did research question, and we were finding the hypothesis and the alternative hypothesis.
Okay. So then it state the null and alternative hypothesis.
Mm-hmm.
All right. All right. So then, are you going over? Okay. So the null hypothesis. I don't know. I'm lost on that part. So we're supposed to take the data link,
Yep.
which I can't, which I've been trying to access, but it's not letting me access it.
If you control and then click it, it should open up.
Okay, it just opened. Just need a second. Okay, what? Factory assembly times.
There's not a lot of data. I can read it off to you if you want.
Okay.
Okay. Do you have the quantitative inference procedures spreadsheet open?
Yeah, hold on really quick.
Okay.
All right, I got it open.
Okay.
All right. So we've got the two different boxes. We got pre-assembly change and post-assembly change.
Yes.
Okay. So we were talking about that. About the whole t-test thing being like one sample and all that. So this is from one sample, but these are, the first one is before, and then the second box is after.
Exactly. So it's before the change and then after the change.
Yeah. So shouldn't that be a paired sample t-test then?
Yes. Yeah. So that's what we're going to put it in on the spreadsheet
Okay.
is the paired sample t-test.
Okay. That makes sense. Okay. I got my I just pasted it. I got my results in.
All right. So I got my t-value to be 1.220 and my p-value to be 0.257 and a bunch of 2's.
Yeah, 1.22.
Yeah.
And
And then
0.25. Yeah, I got the same results.
okay. And then the confidence interval was negative 0.940 and
Yep.
3.051.
Yep.
Okay.
All right. And then so now they want us to state the null hypothesis.
Mm-hmm.
So I mean it says 0 on the graph. I mean, is that what we're going with then? Or,
I'm assuming that the null hypothesis then would be that mu is equal to 0, and then the alternative is that it's not equal to 0.
okay. Okay, I'm looking in the book and it just keeps saying mu equals 0. So I guess
It's just automatically assumed.
yeah, just like how a level of significance is typically 0.05 if not provided otherwise.
Yeah.
Okay, cool.
And yeah. I found the mean of the differences to be 1.056 and the standard deviation to be 2.596.
I'm sorry. Okay, so standard. Okay, and sorry. Okay, so the mean. Say the mean again. Sorry.
So the mean for the differences, I
Is one.
got 1.506.
Okay, or 0.56.
And then this, yeah.
Okay.
And then the standard deviation to be 2.596.
All right. Yeah, that's what I got.
Okay. Then okay, and then I couldn't figure this one out, but it's like how it's asking on number 4 is what type of hypothesis test to use.
You said on number 4. Okay.
Yeah.
Okay. I'm gonna go to the book really quick. I'll do the find button. Type in hypothesis test. Okay, so I think I'm in the right area. Look. I'm not seeing anything on.
Oh, it would be it'd be a two-tailed test. It's the same as what's this saying in the book? Let me read it to you. It's saying that a hypothesis test for two means with paired data is conducted in the same way a hypothesis test for a single mean with sigma unknown. And so the only difference is that you have to find the difference between your data, like the difference between the pairs before you do the single sample procedure, just so like finding the t-score. So that's what it is. That makes sense.
Okay, so right now I think I found something here at the bottom that just to add to what you're saying. It has so we have the null hypothesis as equals 0 and the alternative as
Not equal 0.
So if you go all the way down to the bottom, all the way down to the bottom where it says 5 summary, on the third bullet point, it says the alternative hypothesis can be left-tailed, right-tailed, or two-tailed, and it gives the symbol for each one. So if it's like less than, then it's left-tailed, greater than, then it's right-tailed, and if it's not equal to, then it's two-tailed.
Did you say 5.1?
So on lesson 12 in the book, if you go all the way to the bottom,
yeah,
like all the way to the bottom of the page.
Yep.
It's like the third bullet point in the 5 summary.
Okay. Oh, so when it's not equal, it's going to be a two-tailed test.
Yeah.
That would make sense.
Yeah. I typically find most of the help I need in the summary box. I'll have to look for the future. Okay, so then what type of hypothesis test? Since the null hypothesis is saying not equal to 0, or the alternative is saying not equal to 0, it should be a two-tailed then, right?
Yeah. And then what are the requirements? I know the requirements for a two-tailed test is that the sample mean have normal distribution.
Yeah, because it's greater than 30, right? Wasn't it like 100 people? 100 products.
Let me.
Oh, is it the products, the 100 products, or the workers?
No, it's the number of workers. So that since there are only 9 workers, to be able to determine if it is normally distributed, we'd have to do a QQ plot.
Okay. So then it's a QQ plot, and then that's how we determine whether it's normal or not.
Yes.
All right.
And then I made one, and it does not look to be normally distributed. It's kind of like snaking around.
On the QQ.
Mm-hmm.
So you pasting the differences there, or?
Yeah, so you just use the differences
All right.
when you calculate that. So I would say then that the requirements aren't met because it's not normally distributed.
Oh, okay, that's weird. I tried pasting, copy and pasting, and it came up weird. Paste. Why is it doing that? What's going on? Okay, can you tell me how you put that in there? Because what I did was, and I always do this.
Oh, you can't copy and paste because it's a formula that
Okay.
finds you the differences. So you just have to hand type them in, the numbers.
All right.
So there are only 9, which isn't terrible.
Okay. I'll just take your word for it then.
Okay.
I'm just gonna get us behind.
No, you're good.
So it when you put in the differences, it came out as not normal.
Mm-hmm. Yeah. Then 2. Then we still have to compute the t-score, and I found that to be 1.22.
Yep.
And then the degrees of freedom is going to be 9, not 9, 8.
Yep, that's what I have.
All right. And then I found the, let's see, what are p-values?
P-value 0.25.
7.
Yeah.
And since it is larger than the level of significance, you would fail to reject the null hypothesis.
Yeah, you fail to reject it.
Okay, and then
So with that, with it not being normal, the differences not being normal when we put them into the QQ plot, and the null hypothesis being failed to reject, then that would mean that you don't have you have insufficient evidence to say that the time to make the 100 products is like improving, right? Wasn't that the question?
yeah.
Okay.
Mm-hmm.
Okay. So then that would be the answer for H. Just insufficient evidence.
Then for I, wouldn't you just create a t-distribution and with the 95% interval?
Yeah.
Mm,
Yeah, so 95%.
and then basically for 5, they just need to find another way to try and reduce the time because the way they tried did not work. It wasn't more efficient than before.
Yeah, I took a glance at the answer key, and that's right. Okay, cool.
Right.